Volume and surface area of solids. Now, in this part of the chapter, we'll be learning about the different cross-sections of solids. What is cross-section? Now, when a solid is cut by a plane, the intersection is a plane figure called the cross-section of the solid. Let's consider a loaf of bread. If this loaf of bread is to be cut in a particular direction, and creating in slices of bread that has a particular shape in the lateral surface and a thickness. This lateral surface here is called the cross section of the bread. Different directions of cuts can produce different cross sections in solids. Now let's consider a cucumber. What are the different ways that we can cut a cucumber? For example, if you were to cut a cucumber into half in the following direction, we will be able to get two halves of the cucumber. And where is the cross section? The cross section will be this plane, this lateral face, okay, where this is the cross section. How about if you were to slice the cucumber in a different direction? Cutting the cucumber in slices will result in a circular shape, circular cross section of the cucumber, and this will be your cross-sectional area. Let us consider the case where we cut the solids in the same direction but at different positions. Now let's take a look at the pyramid. If we were to cut the pyramid nearer to the top, we will have a cross section over here. And if you were to cut it further down below at the base, we will have another cross section over at the bottom. What do you notice? The cross-sectional area of the top piece is actually smaller than the cross-sectional area at the base. How about a cone? Cutting it in the same direction horizontally across also results, but at different positions, also results in different sizes of the cross-section. So cutting the cone on top will give a smaller cross-sectional area compared to cutting it at the base of the cone, where this is your cross-section. So for solids who have different cross-sectional area when the direction of cut is the same, they do not have uniform cross-sections. How about the following solids? Now let's take a look at the cylinder. If I were to cut horizontally across this cylinder, at the top, I will have a circular cross-section. And if I were to cut it in the middle, I will have another circular cross-section. And these two cross-sections are of the same size, and they are actually the same in area. Let's consider a triangular prism. For example, if I were to cut it across top down, I will have a triangle in my cross section over here. And if I were to cut it in the middle, I will have another triangle over here. And these two triangular cross sections have the same area. Let's consider lastly a cuboid. So if I cut horizontally across, I will have a rectangular cross section over here at the top and another rectangular over here in the middle. And these two have exactly the same shape and the same size. So they will have the same cross-sectional area. So for solids that if you were to cut them in a particular direction and they have the same cross-sectional area throughout, these solids are said to have uniform cross sections. Uniform cross sections. So these solids have a special name. They are called prisms. In summary, cutting a solid in different planes and direction will result in different cross sections.